Hey guys, good evening and thanks for joining. First of all, apologies from my side because some of the internet issues and network issues. So we will continue. So yesterday we were discussing about the transport layer and also network layer. So layer number 4 and layer number 3. So today I will start layer number 2. So layer number 2 and layer number 2 is a data link layer. Okay. So what this data linker layer will do exactly? It will provide end-to-end communication using media. It will provide end-to-end communication using media. So that is the importance of data link layer. So what is the media here? You can consider from 20th century and 21st century. So there are a lot of improvement from the communication channel wise. So optical fiber communications before 1947, if you want to communicate two countries, so they used to do the optical fiber communication. Later it came to air, water, and also current communication completely based on the satellite communication. Water communication right now it is happening through satellite communication using GSLV and PSLV. Okay, so geo satellite launching vehicle and also polar satellite launching vehicle. So that is the current communication channel whatever right now we are using. Okay, so that is about the different types of medias right now we are using. One is example medias are, am I audible? Hello?
Sir,
Yes,
yes,
sir.
sir.
Yes, thanks. So example medias are, example air you can consider it is one of the media and water is one of the media. So when I say water through oceans, optical fiber communication, that is meant by water. Okay, next one fiber is one of the communication and right now is satellite. So these are all the different types of communications. So what is data link layer will do? So using these layers, communication will happen from one place to another place. Communication will happen to one place to another place. That may be fiber, that may be satellite, that may be physical cable connections also. Physical cable connections also. Those things we can call it as a media. And the data format is frames. So data format is a frame. Frame will use time division multiplexing. So completely based on time. So in the engineering side, I'm not sure how many people are engineering background. In the first year or second year, we studied about frequency division multiplexing and time division multiplexing concepts, right? So frame will use a time division multiplexing based on the time. So how the media channel will go and it will communicate. That is called time division multiplexing. In the similar frequency division multiplexing also. Water frame it is using in the data link layer, it is a part of time division multiplexing. And here we have couple of attacks are there. Those attacks are spoofing category and also flooding category. So when you say spoofing category, example, you can see RARP spoofing. So next one we have MAC flood category. MAC flood attack. So please remember guys, so MAC flood attack will not come here. Okay, in transport layer, MAC flood data, MAC flood attack will not come here. So MAC flood attack will come, it's a part of data link layer. Please differentiate even attacks also. Don't confuse between these attacks. Okay. So that is about data link layer. So data link layer example of the device is anyone. Example device is
Switch, switch.
switch. So example device is switch. Once again, switch has a total 3 different types of switches we will use. There are 3 different types of switch normally every organization will use. It's not a mandatory exactly we have to use 3 switches, but as per the Cisco terminology, we have 3 different types of switches. One is access switch, one is distributed switch, next one is core switch. So access switch, distributor switch, and core switch. So these are the three different types of switches. So most of the organizations, they will use access switch and core switch. So it's, as I said, it's not a mandatory. Every organization has to use every switch. So based on our business requirement, based on our money, so based on our budget, so whether we'll go for the three different switches or maybe one switch or maybe couple of switches, it depends. So types of switches here. So whenever any user is giving any request, always first request will go to the access switch. Whenever any employee or any end user in the organization level, so if is trying to access anything, always first request will go to the access switch. So access switch will broadcast the traffic to the whoever is connected in the LAN. When you say whoever, so that may be printer, that may be router, that may be load balancer, that may be one of the server, that may be one of the application, and so on. Okay. So always first request will go to the access switch. From access switch, it will go and traverse the multiple devices. Finally, so it reach to the destination device. Example, maybe consider one of the employees trying to access google.com. In that scenario, from that particular end user laptop, request will go to the access switch. Access switch, it will go and it will see, and it will broadcast to everybody in the network. From there, it will go to the core switch. Core switch to the respect to whatever google.com domain he requested. So the DNS server, from DNS server, it will go to IDS IPS, then proxy, then firewall, then ISP router. Finally, it will reach to the public or internet. That is the flow. So that flow, I will explain about the network architecture diagram. Whatever right now I said, access switch and also core switch, NIDS, NIPS, proxy, ISP router, firewall, and so on. All these are part of network architecture diagram. There is no need of confusion. I'll explain in the future. Okay. So what is the thing you have to remember? So whenever any end user is giving request to the respective system or server or a database or application or website and so on, first request will go to the access switch. That's what you have to remember. Coming back, core switch. So core switch, it will maintain the entire traffic of the organization. Okay. So example, access switch side, I can say model numbers also. Example, we have seen 2500, one of the model number. Okay, last time. So distributor switch may be 4500 model number. So core switch may be example 6500 number. So these are all couple of Cisco based switches. Cisco based switches. So access switch is always a lower end model, and a distributed switch is like a medium model, and the core switch is a high end model. So these are all the three different types of switches every organization will use. As I said, it's not a mandatory. Every organization has to use all these three different types of switches. According to our budget, according to our requirement, we have to purchase the respective switches. Okay. So switch will broadcast the traffic. It is an intelligent device, once again, similar to like a router. But what is the drawback related to switch? Switch will not provide any internet. Switch also will not provide one more thing. What is that? Switch will not support for
VPN services.
perfect VPN services. Switch will not support for internet connectivity. Switch will not provide for VPN. Okay. So always router will support for internet, and router also will support for VPN connectivity. That may be remote VPN, that may be site-to-site VPN. Okay. So we can see the differences also. So now coming back, examples of protocols. Example protocols. We have anyone. What are the example protocol? One protocol name can you give? One protocol name can you give?
RARP.
Perfect. RARP. So RARP full form is reverse.
Address resolution protocol, right?
Yes, reverse address resolution protocol. So what RARP will do? What RARP will do?
Converts MAC address into the
Convert
IP address.
Yes.
Address number 3 to
Yeah. Convert to MAC address to IP address in simple words. Otherwise, convert to data link layer address to the network layer address.
MAC address.
Yeah. So that is called RARP. MAC to IP in simple words. MAC to IP is called as RARP. Okay, opposite to ARP. That is called reverse ARP. Okay. Couple of times they will also call ARP. In short, we'll call it ARP. Okay, or otherwise reverse ARP. Okay. So that is about example one of the protocol. We have one more protocol is there. P2P. So P2P full form is point-to-point protocol. So point protocol also it's a part of. Okay. So this data link layer. And also there are two sublayers will fall under the data link layer. Two sublayers. Only one layer contain two sublayers, that is called data link layer. Okay, whenever you are going for a couple of companies, they'll conduct written test also. They will ask, okay, in the written test, so one of the layer contain the two sublayers. They will go options like example, presentation layer, session layer, transport layer, data link layer. What is the option is correct one? What is the correct option? What is the correct option? Data link layer. Yeah. So data link layer contain two sublayers. One is LLC, logical link control. Second one is media access control, MAC. One is logical link control, second one is media access control. So what is logical link control and what is media access control? Media access control name itself it is suggesting through media end-to-end communication will happen. Example, we have seen water or air or fiber or satellite. That is called media access control. Okay. So then what is logical link control? Logical link control. So I'll put one here. This is two. So media access control meaning here through media. So end-to-end communication will happen. That is called media access control. Then we will discuss about logical link control. So what I have done before our class has been started. So I have drawn one of the diagram in draw.io. So what's going on to my system? Yeah, you can see this one. So before our class has been started, so I have drawn this diagram. Consider one of the building is there. That particular building contains, there are 3 floors. So ground floor, first floor and second floor. Ground floor, first floor and second floor. Okay. So in ground floor, you can see, are you able to see my screen?
Yes, sir.
Yes, sir.
Okay, done. So in ground floor, ML means machine learning team. So ML, I have mentioned here. ML is another machine learning. So in ground floor, machine learning team is sitting. In first floor, machine learning team is sitting. And also in the second floor, machine learning team is sitting. Even though they are sitting in the 3 different types of floors, okay, physical separation is there. When you say physical separation, couple of employees are sitting in the ground floor, couple of users are sitting in the first floor, couple of users are sitting in the second floor. Physically, they are separated. When you say physically they are separated, physically they are separated. What do you mean by physically separated? Because ground floor is different physical separation, first floor physical separation, and
Your
also
audio
logically
is
they
not
report to same
audible.
director.
Your voice is somehow cracking.
Yeah, some internet issues, I think. Hello, am I audible now?
Sir.
Yes, sir.
Yes, sir.
Ganesh, ask them to stop the YouTube. Give me 1 second, guys.
Okay, sir.
Sorry guys, so many people are watching YouTube shorts. That's why. Apologies. Yeah. So here physically they are separated, but logically they are belongs to same team. Okay. And also they will report to same director. Also, also logically they will report to same director. So that is called logical separation and also physical separation. Okay. In the similar way, so second option you can see DevOps team, DevOps team, and DevOps team. So ground floor also DevOps team is sitting. First floor also DevOps team is sitting. Second floor also DevOps people are sitting. So even this DevOps side also, physically they are separated, but logically they are belongs to same team. And finally, SOC also same as it is. Okay. So that is called logical separation and physical separation. In the computer terminology, logical separation can be done by switch. In the computer terminology, logical link control separation will be done by switch. Switch will support for the logical separation. How it will separate the logical separation? Using virtual LAN. Using virtual LAN. So what is my physical LAN and what is my virtual LAN? Physical LAN meaning here in dedicated data center or room or site. So our networking devices connected together. That is called LAN, you know already. That is called physical LAN also. So example, one of the data center, we connected to load balancer, we connected to routers, we connected to switches, we connected to internet router. So database servers, physical servers, and so on. So that entire data center, we can call it also physical LAN. Okay. So coming back to virtual LAN, virtual LAN normally we will create under the switch. Okay. Every virtual LAN will assign one dedicated ID number. The dedicated ID number, we can call it as a virtual LAN ID. Virtual LAN ID. So why we have to create these IDs for the virtual LAN? For identification purpose. For identification purpose. So example, you can see, I given VLAN ID equivalent to 100, VLAN ID equivalent to 101, VLAN ID equivalent to 102. So VLAN ID equivalent to 100 belongs to machine learning team. VLAN ID 101 is belongs to DevOps team. VLAN ID 102 is belongs to SOC team. Okay. So all these things where we can do under the switch. We can configure this particular configuration in the switch. So this is called logical separation, logical link control. Okay. So in this switch, we can do all these VLAN configurations, whatever separation we are doing, okay, without physical. So that logical separation can be supported by switch. Okay. So how we can define this particular logical link control? Switch will support for a logical separation using VLAN segmentation. Every VLAN has dedicated ID number will be there. For identification purpose. So VLAN ID represents identifying multiple team members information. So that is called logical link control. So everything, the whatever we are using virtual LAN, that virtual LAN contains the logical separation. That is nothing but logical link control. Then what is second one? Media access control. Media access control meaning here whatever main definition is there. So using media, so total end-to-end communication will happen between source and destination. So coming back to here, if you want to communicate, so these two VLANs which will support. If you want to communicate these two VLANs which will support. If you want to communicate these two VLANs which will support, If you want to communicate these two VLANs, which will support within the same switch. Okay, so two different VLANs, if you want to communicate, switch will support. I'm repeating once again. Within the same switch, if you want to communicate two different types of VLANs, switch will support. I'm asking in one way, in different way. If two switches are there, if two switches want to communicate, so what is the mandatory device is required? Anyone? Two different switches are there. If two different switches, if you want to communicate together, one more device we want to configure. What is that? Anyone? Router, yes. So that's what I said. Router. So if you want to connect two switches in the two different locations, or two different, even same location also, same location or two different location, two different areas or two different countries, router is a mandatory device. Router is a mandatory device. Within the same switch, two different VLANs will work. Two different switches, if you want to communicate, router is a mandatory device. Okay, so that is the note I'm providing. Already discussed this one previously, but I'm not sure whether you remember or not. Note. Within the same switch, if you want to communicate, two different VLANs, switch will support. Okay, that is the first note. Second note is two switches want to communicate, router is a mandatory device. Okay, so that is the note 2. So you have to remember second one mainly. Not only that one, even two different locations, two different cities, two different areas, two different countries, two different continents. So if you want to connect two together, so internet is a mandatory. So internet, how, which device is providing? Router is providing the internet. Okay, so that is about overall data link layer. That is about overall data link layer. So I will show you now a couple of examples of switches. Switch 6500 or 2500. So this is the switch symbol, guys. So we have 12 port switch, 12 port, 16 port. So 32 port and also 48 port switches we have. So 12 port, 24 port, 32 port, and also 48 port switches we have. Okay. So these switches can use once again, okay, either RJ45 or Ethernet cable or maybe optical fiber cable connection also. So when we will use RJ45 and when we will use optical cable connection, anyone? When we will use optical cable and when we will use RJ45?
Based on the network, yes, sir.
Based on the network, are you sure?
1
It
GB
is
for RJ45.
Ethernet cable
for up to 1 GB.
1 GB.
Yes, correct.
No, 1 GB we use, sir.
Up to 1
Yeah.
GB
Correct.
RJ45.
Yes, right. So up to 1 GB we can use RJ45 Ethernet. So 1 terabytes or picobytes we will use optical cable.
Optical cable.
Yeah.
Optical.
Yeah, there are two different types of ports we can configure here. One is optical and also one is RJ45. So these switches we can now install in the data center level. This is one of the example of switch. In the similar way, router also look like same as it is, but backend hardware configuration deployment is different. Okay, Cisco 4500 router. Yeah, this is one of the router 4500. So this is the router. So switch and router also look like similar as it is, but functionality wise it is different. Functionality wise it is different. Okay. So this is router. So these routers and switches only we have to deploy in the physical data center. Physical data center. So if you're purchasing switches, routers, load balancers, servers, databases, and it's a very expensive solution. We have to maintain the air conditioner, we have to maintain the ventilation, we have to maintain the plantation. Always we have to keep the cool, and also we have to maintain the carbon dioxide cylinders and so on. That is the reason now everyone is migrating to which one? Everyone is migrating to
Data center.
Cloud.
data center, cloud.
Cloud, sorry.
Everyone is migrating to cloud because it is inexpensive solution and also is very cheap solution as compared to physical data center using hardware devices. Not only because of that one. So one more reason why everyone is migrating to cloud. So maybe these hardware devices, okay, I will give one practical example in our day-to-day life. You are purchasing your laptop today. How many years you can use? How many years you can use? Approximate.
Approximately 5 years.
Okay, 5 years or 10 years maximum. 10 years maximum.
10 years
Yeah.
also we can use.
Yeah. 10 years maximum. After that 10 years, we have to purchase a new hardware device once again. New hardware device we have to purchase once again. So every time purchasing new hardware device, it's a very expensive, and also data refreshment we have to do. Okay, data copy thing we have to do and so on. But if you are doing for the cloud, reliability and elasticity, meaning here, so directly we can increase the space. Okay, there is no need to refurbish that particular module. Okay, there is no need to remove the data and so on. So elasticity is one of the very, very favorite. So term or word in the cloud terminology side. So example, this which I purchased today in my data center, maybe I'm using for 10 years. After 10 years, so what I have to do? I have to do shredding. SHREDDING, shredding. Shredding is nothing but so copy of the data and demolishing this particular device. I have to copy everything as a data into external hard disk device, and whatever new switch I'm purchasing, I have to import that particular backup. It's a lengthy process, it's a complicated process, it is a robust process. But if you are going to cloud level, so we have one of the term is called elasticity. So just we can increase space based on our requirement. That we can see later. So cloud security part. So that is the difference between cloud and data center. Data center is always very expensive solution. So that is about overall data link layer. That is about overall data link layer. So MAC flood and also reverse ARP poisoning attack. So these two will fall under data link layer. Finally, last layer in our OSI.
I have one doubt, sir.
Yes, please.
Here, data link layer is nothing but end-to-end communication through media, right?
Source to destination using physical cable connectivity.
It is only, is it only physical or
Yeah.
Is it only physical? Hello?
It is virtual.
Because now we are connecting through Zoom. Here, Zoom is a media or what, sir? Hello? Hello, sir?
Your voice is chopping.
Yeah.
Yes, please.
Now it is okay?
Yes, please.
Here now we are connecting through Zoom. Now we are here. Zoom is a media or what, sir?
Yeah, Zoom is a media. Through satellite we are connecting internet.
Okay, sir. Now here all the applications, WhatsApp, Facebook, Skype, these are also medias, right?
Yes, correct.
Yeah. Okay, sir.
Internet using media, right? So last, okay, so layer is physical layer, layer number 1. Layer number 1. So here physical layer. So here, so end-to-end communication is happening through physical cable connection. So whatever Tulsi Ram is raised, it's a good question. It is a media virtual way in the data link layer, but it is a completely touchable cable connectivity using physical cable. That is a part of physical. Physical is not touchable. So example, any wires we can take. that may be RJ45 or Ethernet, transceiver, receivers. All these will fall under physical cable connectivity. Physical cable connectivity. Okay, end-to-end communication will happen through physical cables. Physical cables. Example, transceivers, repeaters. Okay. Yeah, so these are a couple of examples of the physical cables connectivity. And also we can say optical fiber cable connection also. Optical
Ethernet.
fiber cable
RJ45.
connectivity. Yeah, RJ45, that's right. Even optical cable, yeah, all these. So physical cable connections. So example, you can see repeaters in networking. So this is one of the example of repeater. So this is one of the example of repeater. So this repeater, it will use to connect that particular physical cable connection, and also transceivers. So transceivers, this one. So using this transceiver, these are physical, not okay, virtual way we are connecting. All these are physically we have to connect it together. Okay. So that is about, okay, optical fiber also example. So difference between data link layer and also respective physical cable. Here we'll use physical cable connections, but here virtual media only we will use. Here virtual media will use. Here physical cable connections we will use. Okay. So example device, anyone? Example device, anyone? I already told you. Example device.
Computer system to printer.
Example device. Hub. Hub is example device for physical layer. Example device for physical layer is hub. It will not support, okay, it is not intelligent device basically. A router and switch is an intelligent device. Hub is not an intelligent device. Okay. So yesterday we have seen one of the concept. So one of the user is giving printout. So switch or router will broadcast to everybody, and printer only will respond back, and switch will validate whether printer is responded back or web server is responded back, or maybe so some of the system is responded back. If printer is responded back, that particular request will go to the user. But on the other hand, if it is hub will not identify who has sent it to, who is the destination, whether correct person is sent it back or not. Hub will not validate. Initially, 1984 or 1985 or 1986, so scientists, they found out hub. Later, they found out switch and router. Okay. So data format, anyone? Data format. Data
Bits.
format.
Bits.
Binaries. Yeah. Bits. Sorry, not binaries, bits. So 0 and 1. 0 or 1. So here it's a physical cable connection. What are the attacks will come? So what are the attacks will come? Physical damage of the cables, physical damage of the cable, or physical theft. So couple of robbers or thieves, they will completely cut the cable connection and they will take the cable to home. So that is like an attack. Physical damage. So physical damage meaning here, so maybe floods or maybe tufan, maybe earthquakes. Because of these reasons, so that cable will become damaged. So these two attacks will fall under layer 1 physical layer connectivity. Okay, that's all about overall 7 layers. Out of these 7 layers, so very important layers are, one is application layer. Why? Because nowadays, past 5 years or 6 years, you can see there are a lot of smartphone revolutions. Initially, when mobile found out, only it is 2000 rupees or 3000 rupees, and it doesn't have so many applications. Okay, now smartphones everywhere, smartphones. Not only because of that smartphone revolution. Second one is spectrum, telecom spectrum, 2G, 3G, 4G, 5G, and so on. Because of these reason, we are getting the cheap internet rate, cheap internet costs. Okay, everybody is purchasing data and so on. So even remote areas also, we are able to access any of the applications like YouTube or Twitter, Instagram, and so on. So 10 years back, this is not the case. 10 years back, this is not the case. So lot of internet related revolution, smartphone revolutions, everybody is aware of applications. Without going to home, without going outside of the home, everything we can so do in home by ordering everything in home itself. Food and water and so on, whatever it may be, shopping, everything we can do in home itself. So everywhere is apps. So that's why application boom is increased a lot. Attackers are hacking all these apps as well as applications. So that's why application layer is one of the very important. Second one is obviously network layer. Network layer. Anyone, why network layer is important? Why network layer is important?
Because
Anyone?
application requires network.
Because application required network.
Yes, sir.
To
It
get
uses
the information to application.
it needs router, etc.
Because
I need
it
correct
also,
answer.
because I think it is time saving. Time is important here. And even media streaming apps right now, they use network layer.
So network layer, why it is important? Internet. Which layer internet will work? Which layer
Network
internet
layer.
will work? Network
Network layer.
layer. Yeah. So through internet only most of the attacks will come. Without internet, we have less chances are there. Without internet, we have less chances are there to receive the hacking part. Only because of the internet, so we will receive a lot of attacks. Cyber is nothing but internet related. Cyber cave, internet cave. Okay, most of these attack will come through internet. So internet will work under which layer? Network layer using router. So that's why layer number 3, network layer, and also layer number 7, application layer. These two layers are very important. Most of the attacks will come to these two layers only. Okay, so now I will give couple of interview questions here itself. Explain about OSI layers. So most of the interviews, we can expect this type of interview question. Explain about OSI layers. Okay, so whenever you're explaining about OSI layers, you have to say the top to bottom or bottom to top. So top to bottom is always better. So layer 7 to layer 1. Why it is better, I will explain later. Second one is so encryption will come under which layer? So that is the second one. Third one is, what is encryption? What is encryption? Fourth one is, what is the difference between encryption and hashing? Give me 1 second, guys. I will quit this particular notifications. Give me 1 second. I will log out my Microsoft Teams. Apologies. Yeah, what is the difference between encryption and hashing? It is also one of the favorite interview questions. So hashing I will explain later. So far we completed only encryption. So next one is router will come under which layer?
Network layer.
Yeah, switch will come under which layer? What is ARP? Okay. What is RARP? So next one is, what is data format in each and every layer? Each and every layer attacks. Okay, one of the end user is accessed, or one of the end user is given google.com in the web browser. What is the backend process? So I'll filter out once again. So under this one, what are important? So as I said, I can make 1000 interior questions in this itself, OSI layers, different ways we can ask. So explained about OSI layers. So you have to explain all those 7 layers. Difference between encryption and hashing. So far we know about only encryption, hashing will explain later. And what is ARP, address resolution protocol, and each and every layer attacks. Next one is, one of the end user is given google.com in the web browser. What is the backend process? I'll explain this one. So example maybe now here I given www.google.com. So what is the backend process? That is the meaning basically. So what the question here? So one of the end user is giving google.com in the web browser. What is the backend process? So here web browser I given just a google.com. What the backend process? So here you have to say it will follow OSI layer approach. It will follow OSI layer approach. Actually, this concept you can explain 3 ways. This particular answer we can give in the three ways. One is OSI layer approach. Second one is DNS resolution. Even if I'm giving google.com here, so this google.com can be resolved into respect to IP address backend. That is also one of the answer we can give. Third one is SSL TLS mutual authentication. SSL TLS mutual authentication. So this answer we can explain 3 ways total overall. So 98% of the cases, whenever they will ask this particular question, so most of the cases interviewer is expecting from OSI layer approach only. So what is DNS resolution, and also what is SSL TLS mutual authentication? We are going to discuss about in future. So right now it concept has come. I will explain about this particular topic. So now google.com, it's a website. So website will come under which layer? Website will come under which layer?
Application layer.
Application layer. Yes. Application layer. What is data format? What is data format?
Message.
Data.
Message.
Data.
Data.
So this particular data, once again, once the user is accessing, so one form of web browser is converting to another form of web browser. So google.com is converted into, once again, data here using which layer? Presentation layer. Using presentation layer. So next one is session layer. Session will be established between example, my browser to the backend Google server. My browser to the backend Google server. So once again, what data format? Data. Okay.
Data.
So now this session will be converted into segments. This session will be converted into segments. In which layer?
Transport.
Transport
Yes.
layer.
Transport.
Segment. Okay, this segment we can be converted into IP packets. Segment can be converted into packets. Which layer?
Network layer.
Network.
Yeah. IP packet. Packets can be converted into frames. Which layer?
Data link layer.
Data link.
Data link layer. Finally, so my computer will understand. My computer will understand 0 or 1. So nothing but bits. Physical layer. Yeah. So first three layers are same till connection will be established. So google.com, once the end user is giving google.com, so that is application layer. In presentation also, once again data and session will be established. So in the session data, so data can be converted into segment can be converted into IP packets can be converted into frames, so frame can be converted into 0 or 1. Finally, user is able to understand, computer is able to understand. In such a way, user can open the google.com. This is the backend process. Okay. So that is about OSI layers. Now we have one more concept. These OSI layers are converted. Total how many OSI layers? We have 7. These 7 OSI layers are converted into 4 layers. Those 4 layers are TCP IP layer. You can see here a lot of duplication is there, especially data wise, data format wise duplication is there. Data format wise duplication is there. So what these scientists they have done, so they reduced or they compressed OSI layers into TCP IP layers. So 7 OSI layers are converted into 4 TCP IP layers. Okay. So once again, this particular, you can see I have created one more tab here under the Excel sheet. So before our class has been started, so I have drawn this particular table. So total, these are all OSI layers: application layer, presentation layer, session, transport, network, data link, and physical layer. Okay. So reduced version of OSI layers is called as TCP IP layers. Reduced version of OSI layers is called TCP IP layer. So how they reduced? So these 3 layers they reduced and compressed as one layer. So that is called as application layer. Application, presentation, and session reduced or compressed as a application layer. Transport is transport only. Network name they changed as a internet, because in network layer only internet will work. So this one is changed as internet. So previously Tulsi Ram is asking one of the question, right? So physical media is different or physical cables are different? Both are different. So always data link layer will use a physical media using physical cable connection. It is like a hand in hand. So these 2 layers are divided and compressed as a network interface. Network interface like RJ45 or Ethernet cable using media, using satellite or maybe air or water or maybe some other media options. So these layers is fall under TCP IP layer. How many layers are there under TCP IP layer? We have 4 layers are there. One is application layer, one is transport layer, next one is internet layer, next one is network interface layer. So couple of times, so NOC team and SOC team, I told you already. I'm not sure how many people remember NOC and SOC. So NOC team and also SOC team. I will give one more practical scenario. So Facebook is got compromised in March 2022. March 2022. So network outage has occurred. Because of that reason, $6 billion loss. Okay, network outage has occurred. $6 billion within 4 hours of time period. So in that particular network outage is occurred, we have to troubleshoot why that outage, why availability has occurred. In that particular scenario, what we have to do? We have to do the packet capture. Packet capture, that is called PCAP. PCAP is called packet capture. Shortcut is packet capture, PCAP. So full form is packet capture. Whenever if you want to do troubleshooting or whenever if you want to do debugging or troubleshooting, nothing but some problem will come. That problem is called as debug. Some problem will come. If you want to solve that particular problem, so we have to debug or we have to troubleshoot. Finally, solution we have to provide. Okay. troubleshooting or debugging means whatever problem has occurred. So we have to solve that particular problem, and finally solution we have to arrive. So that is called as debugging or troubleshooting whenever any problem will occur. Okay. So now packet capture, where we have to do whatever inbound traffic and whatever outbound traffic is going on. So which tool most of the case inbound traffic and outbound traffic it will monitor? Firewall. Firewall. So as I said, Facebook 2022, it is got compromised through network outage. In that scenario, Facebook company has to go to firewall and they have to see so source and destination. They have to do the packet capture. What is the last session in the firewall? They have to do the source and destination, and they have to download the packet capture file, PCAP file. Once you are downloading the PCAP file, then we have to come to Wireshark. So Wireshark is one of the network traffic analyzer. Network traffic analyzer. I already provided in course content. I'm not sure how many people remember. So you can see here Wireshark. Wireshark. So Wireshark is a network traffic analyzer. If you want to troubleshoot something, if you want to debug something in the packet level, we will use Wireshark. Wireshark. So that is open source tool. Example Wireshark. You can go and you can type in the Google. So this is the Wireshark tool. It will do the packet capture analysis or network traffic analyzer. So go to here and download the packet capture wherever you are downloading. If you are downloading the Linux, you have to download related to Linux related file. If you are downloading the Windows, then you have to download the Windows. Just click on Windows installer. So my bit size is 64. I am downloading Windows installer 64-bit. After downloading, we have to install the file. We have to install the file. So this is called agent basically. So we have to install this particular file. So already I think in my system already Wireshark is there. Let me check. Yeah, Wireshark is there. So after downloading, what you have to do, just click on next, and finally finish. That's all. So finally, Wireshark tool install in your system. Wireshark is an open source tool. It is a network traffic analyzer. Okay. So now after installing Wireshark tool, we have to go to the Wireshark. So now whatever file you are exported from the firewall. So as I said, I'm giving example Facebook. So Facebook company, they have to go to the firewall and whatever last session is there, source to destination packet capture file, they have to export. After exporting, they have to import here. Okay, I opened here now. So we have file, we have to go and we have to import. You can open this open. So you can click on open and import from Hexademp also there, and also open is there. Anything is fine. Either you can open or either you can import from Hexademp. So whatever file you downloaded from the firewall, okay. So you have to import here. After importing, we have to troubleshoot. So exactly where is the issue? Whether issue is there in the which layer? Whether issue is there in the application wise, whether issue is there in the network wise, whether issue is in the transport layer wise, whether issue is there in the network interface wise. Why I'm explaining Wireshark now? So what is the reason behind this one? See, Wireshark always will give TCP IP layer information. So Wireshark analysis always will give TCP IP layer information. It will not give OSI layer information. That is the reason I'm explaining now itself. Whenever you are debugging or troubleshooting, whenever any issue related to incident is coming, in that scenario, packet capture we have to do in the firewall. Once you are doing the packet capture, you have to export that particular PCAP file, and we have to come back to the Wireshark tool, and we have to import that particular file in the Wireshark. Then we have to analyze TCP IP layer information. So now once you are importing, we can see whether issue is existing in the application level, whether issue is existing net transport layer level, whether issue is existing on internet layer level, whether issue is existing at network interface level. Finally, we will come to know issue is in the application side, issue is there in the transport side, issue is there in the internet side, or issue is there in network interface side. Finally, Facebook company identified issue is there in the network interface side. Network interface side. Nothing but either data link layer or maybe either in the physical layer. So for that troubleshooting purpose, they took 4 hours time. That 4 hours time, how much business loss? $6 billion USD business loss. Okay. So that is about TCP IP layer. TCP IP layers are 4. So whenever we are doing the analysis of the Wireshark tool, it will give TCP IP layer information only. So I'm opening once again Wireshark tool. You can see right now. Give me 1 second. Even you can do traffic analysis of your own Wi-Fi also. So this is Wi-Fi. If I'm clicking on Wi-Fi, whatever right now in my laptop is connected. Example, I connected to one of the SSID. This is called SSID. Few virus found. This is called SSID, guys. Single set identifier. This is one of the wireless terminology. We will ask Wi-Fi name. That is wrong terminology, basically. We don't know that is called SSID. Okay. So we'll ask Wi-Fi name. So this is SSID. So right now, whatever traffic is going in on my laptop in the internet, right now I've opened, you can see. So I opened, so this particular drive, I opened one of the document here, one of the Excel sheet here. Right now I'm giving one more google.com website or facebook.com website. Facebook.com website. Now all those data we can see in the Wireshark tool, because so even opening the website also, packets will send and packets will receive. Packet will send and packets will receive. Inbound traffic and outbound traffic, wherever I am sitting right now. So packets will send and packets will receive. That particular traffic we can see under the Wireshark tool. Wireshark tool. So there are different color combinations we have. One is yellow, one is blue, one is ash color, one is red color, and so on. Red color is a dangerous one. There is the issue. Whenever anything you can see here red color in the particular screen, so that is the issue. So whether packet is a retransmitted, whether packet is a dropped, or whether packet is rejected. Okay, so that is the issue. You can see here now. So whenever if I'm clicking anything here, it will come. This is one of the packet now. This is one of the packet. Frame will come under which layer? Frame will come under which layer?
Data link layer.
Data link layer. Yeah. Ethernet 2. Ethernet 2 will come under which layer? Ethernet link will come under which layer? Ethernet 2. Physical layer, physical cable. So that's why you can see D-Link. I'm using D-Link router in my home. So these two will fall under which? These two are combined together. What we can call it as per TCP IP layer. These two are combined together. What we can call it as?
Network interface.
Network interface. That's right. Just now we discussed. Internet protocol will come under which layer? Internet protocol will come under which layer?
Network layer.
Network layer. Internet layer, you can say. Internet layer. Okay. So user datacom protocol, UDP will come under which layer?
Transport layer.
Transport layer. Data will come under which layers per TCP layers?
Last binary.
Application layers.
Application layer. It's clarified, right? So why Wireshark is giving only 4 layers information? So only 4 layers are there. One is network interface, one is internet layer, one is transport layer, one is application layer. So go back here now. So this is application layer, transport layer, internet layer, network interface layer. Same thing we have seen practically also in Wireshark. Wireshark will not give separation of like this. So it will give only these 4 layers information. So most of the people will confuse between TCP IP and OSI. If they'll ask how many TCP IP layers are there, they'll give answer is this one. That is wrong. That is wrong. Okay. So that is about overall TCP IP layers. Coming back here, what is data format? What is data format? Application layer data format.
Data.
Data. So once again, I will discuss. Okay, so Wireshark in future. Transport layer.
Segment
Segment. Only segment. Only segment.
and acknowledgement.
And
Acknowledgement.
datagram.
Datagram. Internet layer.
IP packets.
IP packets.
IP packets. These two combined together.
Frames and
Frames and bits.
Frames and bits. Yes. So 0 or 1. That is about overall difference between OSI layer and TCP IP layer. So now one more definition we want to complete, that is nothing but router and switch. Router and switch. You have to say, guys, this one now. Please go ahead.
router
First-
is an intelligent device.
Intelligent device. Okay, intelligent device.
It is a
What-
network device.
Which is
What
a
about-
non-intelligent device.
Which is non-intelligent device.
Intelligent device.
Intelligent
Switch
hub
is
is,
intelligent. Hub is not intelligent.
yeah. Next one.
Router will has internet and VPN.
Yes, perfect answer. That's what I'm expecting. Router will support internet. Router will support VPN. This is
Yeah.
main difference, guys.
Okay, sir.
So switch will support? Switch will support or not?
Switch will not support internet VPN.
Yes, switch will not support internet.
On the VPN.
Switch will not support VPN. Next one. Next one.
Router will have IP address.
Router will have IP address.
Switch will have MAC address.
Yes, switch has MAC address. So that's why this is called media access control, physical address. Okay, next one.
Layer number 3.
Layer number 3,
Layer number 2.
layer number 2. So better you can say router will come under layer number 3, switch will come under layer number 2. Okay, next one.
Yes.
Next one. One more is there. Two more are there.
Connected with multiple devices.
Yeah, broadcast the traffic, multiple devices, right? Broadcast the traffic. Here also broadcast the traffic. One more definition. One more difference. Last one.
Router will use IP packets.
Perfect. Router will use IP packets.
Switch will use frames.
Yes. Switch will use frames. So these are all difference, guys. It is not interview question. Just for information, I'm saying this one. This is not interview question. Okay. So that is about overall OSI layers and also TCP IP layers. So remember, what is the thing you have to remember? Wireshark tool will give TCP IP layer information. Wireshark tool will analyze network traffic analyzer. Okay. We have two more things we want to discuss. Give me 5 minutes. So TCP packet and IP packet. TCP packet and IP packet. Okay. So this is complicated. That's why I did not draw in front of you. So I have taken from the Google. So this is called TCP packet, guys. TCP transport layer. So this is the format, backend format. So TCP packet contains 32-bit source port and destination port, sequence number, acknowledgement number, sequence number and acknowledgement number. So we are using TCP flags. How many flags we are discussing so far? How many flags we discussed so far?
Flags. 6 flags.
Total
Six
6 flags we have.
Yeah.
So what are the flags you know?
Acknowledgement. Fin.
Synchronized.
Sync, acknowledgement,
Finish.
Yeah.
Reset,
reset, push,
urgent.
Yes, perfect.
urgent.
There are 6. Yeah, right. Everyone is right. Thanks. So there are 6 TCP flags are there. One is synchronization, second one acknowledgement, third one is finish, fourth one is reset, fifth one urgent, and last one is push. These are all the 6 flags are there under the TCP. Okay. So here acknowledgement number means that one only ACK flag is there, right? That is acknowledgement number. Every segment has segment ID or sequence number. Every segment has segment ID or sequence number. So this is the sequence number. Without any error control, without any errors, that means error control will do transport layer using sequence number or segment ID and also port number. So destination has to reach the message or data with meaningful way. How is it possible? Using sequence number, segment ID, and also source port and destination port. I given how are you example. Hope you remember. So acknowledgement number, nothing but acknowledgement flag you will use. That is all segment has a segment ID has acknowledgement number also. Data offset reserved. So reserved can be used for the future purpose. Future purpose flags. You can see flags here. These flags are 6 flags. Total 6 bits it will use. So here flags means TCP flags. So those TCP flags are synchronization, finish, acknowledgement, urgent, push, and also reset. So those flags are belongs to this one. Next one, window size. How much time it will take to respond back? That is called window. Checksum. Okay. Everything, every packet it is traversing, it will check. And urgent pointer. If you are enabling this one, so priority is always number 1. Urgency. If you are going to hospital, any emergency condition will come. Will they take in token? Will they take token? No. So without token, they will go because it's emergency condition. Same thing here also. Whenever we are using urgent pointer or urgent flag is enabled, so that is high number priority. It will ignore existing whoever is there in the queue. So that we can discuss tomorrow. So options, padding. Padding is nothing but whatever unused data is there, that is called padding. Unused data. So those data can be eliminated or deleted. So finally data. So in short, so this is TCP segmentation and also TCP packet. But we will not use this particular packet basically. Always, whenever any packet is traversing from source to destination using internet, we will use always IP packet. This is the packet we will use. IP packet. Okay, net flow data, inbound traffic and outbound traffic. Traffic always in the form of IP packets. IP packets. So IP packet structure is this one. So in short, what is the IP packet architecture? In short, IP packet architecture. In short,
Source IP, destination IP.
that's all.
Payload.
Yeah, both. So
header,
every
payload.
yes, IP header and payload. IP header and payload. Every IP packet contains IP header and payload. So whatever right now I'm sharing in the screen, this particular bigger IP architecture diagram, in short, we can represent as a IP header and payload. IP header will represent once again source IP, destination IP, and payload is nothing but data. So piece of written code. You can see up to here version 2 options. Version 2 option is enter is IP header. Version 2 up to options here. So 1, 2, 3, 4, 5, 6. Up to 6 rows. So everything is like a IP header. Source IP, destination IP. In short, we can represent. And finally, payload is a data. Payload is a data. Okay, in short, we can represent as a so IP header and payload. Nobody will ask, but I want to explain backend also. What the backend architecture looks like. So this is IP packet backend architecture wise. So version meaning here, whether it is a IPv4 version or IPv6 version. Whether it is IPv4 version or IPv6 version. There are two different types of IP versions we have. One is IPv4 and one is IPv6. IPv4 bit number is IPv4 bit number is
32,
32. IPv6
64.
64. Are you sure?
Yes, sir.
IPv6. IPv6.
128.
128. 128. IPv4 is 32. IPv6 is 128. Right now, are we discussing IPv6 or IPv4? This one.
IPv4.
Yeah, IPv4. Yeah. So IHL is nothing but internet header length. Internet header length. Every packet has internet header type of service. So it will use ICMP protocol. I told you, right? Every IP packet with a ping command. Ping command has ICMP protocol as a service. Total length of the packet 16-bit. That one. Identification of the IP packet. Next one, IP flags. We have 3 flags are there, but you can ignore that one. Next one, fragmentation offset. Time to live. So example, if I'm going to ping command, you can see ping google.com. You can see TTL. Are you able to see TTL here? TTL means time to live. Time to live. So that is the meaning of backend here. Time to live. TTL. How much time it will take to reach the destination that will come back. That is called TTL. So in this scenario, right now I given ping google.com. It is taking total 58 milliseconds. Time to live is 58. Okay. Next one is protocol. IP protocol, obviously header checksum. Every packet, it will check whenever the packet is traversing source IP and destination IP. Next one, source address and destination address. Source address meaning here where the packet is originating. Destination meaning here where the packet has to reach. That's called destination address. Options, just unused data. And finally, piece of written code or message, that is called data. So this IP packet. So whatever you can take, guys, that be WhatsApp message or Facebook message or accessing website or accessing server, okay, sending an email, everything in the form of IP packets only. Everything in the form of IP packets only. That IP packets backend architecture is this one. In short, we can write as a IP packet equivalent to, I think I given already. Yeah, I given already. You can see IP packet equivalent to IP header and payload. So source IP, destination IP, and also piece of written code. Okay. So you can remember this one. That is more than sufficient. There is no need to go to this one. Okay, please go through this one. And if you have any queries, please let me know in tomorrow class. Tomorrow I will start IP address classification. Tomorrow I will start IP address classification. Okay. So where is this particular diagrams I'm attaching? Hope you have access to this particular folder. Do you have access to this folder or not?
Yes, sir.
Yeah. So this whatever right now I'm sharing in my screen, IP packet and also TCP packet and everything. So I'm putting under cyber security diagrams. Cyber security diagrams. Okay. So that's all for today. So we'll continue tomorrow, guys.
Okay, sir.
So-
Thank you.
Yeah, thank you so much and good night. See you tomorrow.
Thank you, sir.
Hello. Hello,
Yes, please.
sir. Actually, I'm listening every day's class of you. So how to prepare, sir? Because the next day, whenever you are putting all this video in the group,
Hmm.
I'm just opening and watching, and I'm just recollecting and writing somewhere when I missed something. So how to prepare, sir?
Hmm.
Because whenever you are asking some questions, most of the people are giving the
Hmm.
answers, and I'm
Hmm.
unable to give the answers. So yeah, that is what my question: how to prepare and how to go through, sir.
Yeah, Preeti, first of all, don't compare yourself with others always. This is first
Yeah.
and foremost, as a brother or as a teacher or whatever it may be, I'm giving advice to you. So don't compare yourself with others. You are unique in this entire universe. You have your own talent is there. So they are practicing, maybe you are not practicing and you are less practicing. So already couple of people listen the classes in the previous batches. Those people are already there and they are also listening. Are you getting what I'm saying?
Yes, sir.
Couple of people already they listened the classes in the previous batches. Once again, they are listening these classes second time. Okay. Couple of people already they are practicing and continuously they are spending maybe 5 to 8 hours. Maybe that is the reason. But don't compare yourself with other people. But you can practice just for 1 hour or 2 hours per day. That is more than sufficient.
Yeah,
So these are all not at all indirect
I'm
question.
just not
Whatever I'm giving.
comparing. Yeah, I'm not
Mm.
comparing with the other, sir. Also, if I wanted to give the answers, so how much time should I spend on this practice?
Just you can make a 1 hour per day. That's all.
Okay. Yeah.
1 hour per day. So as I said initially also, first 1 week, it's a completely new to you. So different background of the people of educations will be there. Example, so BTech or Bachelor of Degree related to BCom, BSc, BZC, MSc, okay, MCA and so on. So because already those couple of concepts are belongs to engineering background. Couple of concepts, whatever we are discussing, engineering background concepts are there. Okay. So that doesn't mean that you are not a talented girl. Okay, don't think in that way. Just you can practice Preeti for 1 hour. That is more than sufficient.
Sure, sir. Sure. Thank you so much.
Yeah, you're welcome.
Sir,
But
please
don't
upload the-
demotivate. Yeah.
Sir.
Don't demotivate yourself, Preeti.
So I'm very much confident on this. So that is why I'm asking so many questions, whatever are getting in my head.
Yeah, that's perfect. Really appreciate for that one.
Thank you so much.
Sir, please upload the session after the class, sir.
Yeah,
Actually, please do-
today itself. Apologies. Actually, today I'm so much busy. Apologies. Today itself I will upload.
Yes, sir. It will help us for after the class, sir, to practice.
Yeah, sure, Monica. Sure, Monica. I will do that. Yeah.
Thank you.
Yeah. Okay, guys. Thank you so much. See you tomorrow.
Thank you, sir. Good night.
Good night.
Yes, sir. Bye, sir.